Welcome to this session. We're going to do. We'll have an introductory part here with just some talking about soil health, threats, principles, a little bit of an introduction on farmer research networks, and then we'll have 3 global examples from FRN research on soil health, which doesn't mean that there are so many other examples we could have taken from the work going on within the different communities of practice of the CCRP. But these are just ones that we wanted to highlight because I feel that they express some of the principles that we'll be talking about. Just to quickly, many of us have seen lists like this. What are the limitations? What are the challenges around soil health, especially in smallholder farming systems in tropical areas? I would just highlight a few of these. This idea of returning nutrients and regenerating soils, that's a big one for me. Many people are focusing also on these weed and soil-borne diseases, especially in more intensive cultivation. And a really important one is this reliance on chemical inputs and sort of the sense that because of some of the factors that Ruth Richardson was addressing this morning, this idea that somehow smallholder farmers can in fact be transitioning away from some of the more traditional systems towards almost sometimes exclusive use of chemical inputs, and away from these more sustainable ways of managing that involve organic matter and fallowing. There are reasons for that, and those we've been talking about. I really just want to highlight one of the principles here is the fundamental importance of soil carbon. Also, people call it organic matter. These are somehow synonymous. And just the different benefits that this has, and really the essential need to keep it in the soil, not just for this one over here, which is climate change mitigation at the right, but for all these other benefits that lead to resilience in smallholder systems and better water holding capacity, nutrient delivery to crops, those sorts of things. So just to look at some of the information, some of the data we've gathered with projects, many of them FRNs over the years. And again, I'm crediting here all the important work that these different projects and networks have done. So these are graphs at the bottom showing kind of from different regions. 3 of them are represented here. Malawi is also the important center of a lot of work with an FRN working on soil health, the Best Bets project. We can see with these graphs that, if we look at the levels, which are along the left-hand side of each graph, we can see that in these drier areas like Burkina Faso and Malawi, soil carbon is a real problem. And what I've put on here now are the bands which reflect kind of low and very low levels. And you can see how many of those fields are falling into it. From the sampling we've done, it's interesting that some of the wetter areas in these regions, there's actually in some ways some success stories and a need to really protect the organic matter that's already there. If you can see in Western Kenya, we were surprised to find that there's some relatively high levels of organic matter, especially in flatter soils, which have been receiving probably runoff and things. I'm going to really move ahead because I want to make time for the presenters. This is another key thing that I think maybe people don't realize, that there's been a real revolution in soil science in the last few years, and that we're increasingly moving away from the idea that carbon or organic matter in soils is stored by these very complex like humus or things that we make out of compost. Those inputs like compost and manure are still very important, but what we're coming to realize is that the durability of soil carbon and its role in the soil is really more about aggregation. So the clumping of soil, that is really a biological phenomenon that results from roots, from fungi, from these organisms we call engineers like earthworms and termites and ants, that those are the ones which protect organic matter and keep it around. So that's like a real fundamental change in soil science. And the other kind of fundamental change I want to mention here is that we're used to, or as researchers especially, or as policymakers, we really want to focus on this long-term asset. How much carbon can we build up in the soil? And this is a very laudable goal for carbon mitigation. But really, when we're addressing the smallholder environment, there are these short-term benefits that result from organic matter, from the cycling, the breakdown, the use of organic matter by these different organisms in the soil. And roots are especially important in that. So root biomass, returning roots to the soil is important in that. And so we can think of this not like a long-term bank account, but this idea of quick income or cash flow that's also important in the above ground economic world of smallholder farming. And that this is really revaluing this, I feel, is important. So particulate organic matter is something we focus on as one of the tests we have in a toolkit to address, kind of conceptualize, well, what is going into soils, either from these organic residues, from compost, from manure, from plants, and maybe even from these regional bionutrient recycling loops that were addressed yesterday. So very quickly again, and I believe that the speakers will speak to these principles as well. What do farmer research networks bring to the table for soil research? So it's a forum for exchanging ideas and for really putting on the table in an equal valuing farmer knowledge and researcher principles or global knowledge. Really providing what I think of as very rigorous tests, because we're really focusing on what farmers are interested in and representing their existing systems in a real way. Larger scale, and maybe that's a question we'll get into, whether, you know, how functional has this been for doing large scales, and maybe creating these large data sets that can help to address the need for evidence, as well as social and gender dimensions. So just quickly, these were the guiding questions that I gave the speakers. They may address other ones, they may not address all of these, but it's just kind of a sense of we had a common basis for looking at the different presentations. So it's about a quick summary, principles that you employ here, barriers and key advantages, and what's special about an FRN in pursuing this work. So these are the three cases, and I'm going to continue with the slides here, but at this point I'll stay on, and I want to welcome John Ojem. I'll just quickly introduce actually while I'm here right now. So John Ojem works with the Multipurpose Legumes Project and with a Farmer Research Network trial. He's from Kalaro Kibos in Kenya. Catherine Mesa works with Grupo Yanapai in Peru, and she works on a project that I'm also involved in with forage-based shortened fallows. And then from Burkina Faso, we have Chumba, and I'm sorry, I didn't get this on the slide. Peter Gubbles will also be presenting with Chumba Burgu on farmer-managed natural regeneration with trees on Burkina Faso. And with that, I think I'd like to welcome John into the conversation. And John, I've saved you half a minute, I think. I'm at 7.5 minutes, and I'm going to give you 8 minutes to explore the slides you have. And I'll give you a warning when I'll give each speaker a warning when it's 2 minutes. So thank you. John, whenever you're ready, and I'll get this onto your first slide.
Okay, thank you, Steve. Are you going to show the slides as I speak, or?
Yes, I can advance them for you. Yeah, thank you.
Okay, so thank you once again. The practice that I want to talk about is that of using legume biomass and other inorganic inputs in the smallholder farming systems of Western Kenya, primarily to improve soil health and also provide other benefits to smallholder farmers. So we have farmyard manure and compost, but we're also interested in looking at what lab biomass can do, because we know that lab is a crop that produces a lot of biomass, and that biomass is good for soil health, is good for strider suppression, and is also good as fodder for livestock. But again, we're also exploring how much of this lab can be used by farmers for food. So in fact, bridging the gap in food deficit, food security issues. So what are the benefits that this can bring to the farms? We can talk about soil nitrogen supply, organic carbon being increased, soil cover. We can talk about recycling of nutrients through biological nitrogen fixation. In the case of lab, but also recycling nutrients through compost, crop residues, plus farmyard manure. We can talk about increasing soil moisture holding capacity. So these are benefits that can come from these different organic inputs. And this is what we are trying to push in Western Kenya. So the next slide, please.
I'm working on it. Sorry. Let's see if I can just here.
So we're just looking at what are the some of the agroecological principles that we apply with these practices. And the first thing I can talk about is sensitization and capacity building is leading to co-creation. And that is a very important aspect in terms of getting farmers to learn how to do research with researchers and learn how to solve some of their problems. So that is a very important principle. Contributing to environmental conservation, improving ecosystem health and services through practices like nutrient recycling, striker separation, and additions of soil carbon. So carbon sequestration. We can talk of organic synergy, particularly use of organic and inorganics together is potentially can reduce the over-reliance on inorganic fertilizers, which are harmful to the environment. And we can talk about resilience, putting a lot of legumes in the system for food, but also this is helping us to cope with drought and parasitic weeds like striga, and of course, biological control of pests and diseases, which are very important for sustainable productivity. Next, please. So soil health management is time consuming, but it is also knowledge intensive. So a lot of capacity building of farmers is necessary. So before we started capacity building, we did a survey to find out what was the level of farmer knowledge on soil health and the practices that they engage in. And we found out that surprisingly, most farmers knew that some of the things that they were doing, practices that they were involved in, were actually degrading soil. But they had a problem telling us which specific practices were the ones that were the culprits. And we then did another survey after we did capacity building, and we were trying to look at what farmers have learned. And the graph to the right is showing farmers' assessment of the knowledge that they had gained after sensitization and capacity building. And it was encouraging that quite a number of farmers were saying they have gained either much or very much knowledge from what we did. Next, please. So I'm just going to go quickly through this. I said that lab is important. Lab can generate a lot of biomass, up to 10 tons per hectare. In the system where we are working, and we are trying to push lab into these systems to be used in rotation with cereals, because we know nitrogen is one of the limiting nutrients in these systems. Striga is another important constraint to cereal production. So by pushing lab there and growing it in rotation with cereals like maize or sorghum, we're able to push the cereal yields up. Again, I said that lab is kind of a multi-purpose legume. So there are farmers who are primarily interested in lab for food security, others for fodder, others for soil health, and others for striker separation. So our strategy is to give farmers a diversity of cultivars of lab, so that those who are interested in grain and soil fertility, striga, and so on and so forth can find a variety that can fit that purpose.
I'm sorry to interrupt. You have 2 minutes left. 2 minutes.
Farmers who have a lot of interest in grain, we have got the legumes, lab that are for grain, for soil fertility, and for striga separation. Next one, please. Using compost and farmyard manure is another thing we are doing, and we are trying to recycle nutrients via these routes. We have got 3 sites where we have worked with this, and you can see from that graph that there's kind of a response gradient. So our explanation of this is that these three sites are representing a chronosequence, time since conversion from forest to agricultural land. And if you look at the site that is at the left, this is a site that has been, depleted for over 100 years and is less responsive compared to the site on the right. And we are saying that such a site that is less responsive will require much time and more capacity building of farmers to get it to perform well. Please, next. Some challenges: capacity building must go on because it is essential for soil management. Farmers who are resource poor have got problems recycling nutrients because of biomass and labor issues. Land scarcity is a challenge to legume rotations, as we can probably think. And appropriate legume cereal rotation practices have not evolved because it is a challenge to grow a very high biomass producing legume with a cereal. But there are also advantages. Most farmers have access to crop residues they can use. Majority of farmers have livestock, so they can have access to farmyard manure of certain quantities of this. And most farmers can be able to grow legumes, and incorporation of organic resources, in organic use of organic resources and okay, I'm unable to. Things are changing fast, and I'm able to conclude. Okay. Incorporation of organic resources reduces reliance on inorganic fertilizers. I'm just concluding. Next. So advantage of FRN platforms, they offer great opportunity for knowledge exchange between researchers and farmers. Sensitization is made easier. Large numbers can be reached, which is good for testing in different circumstances. But capacity building has to go with this. And the other advantage is that with large numbers, you're addressing both farmer diversity and ecological diversity, which is a good thing for testing and getting the extent to which your options can function.
Thank you. Yeah.
So that is my last slide.
Wonderful. Sorry. And I'm very sorry that the space bar is at the one time to advance the slide, which I didn't know, and also to come in to advise you about the time. So I'm very sorry that it jumped ahead like this.
It's okay.
Great. So thank you very much. And again, we're taking questions in the chat. So we have a few comments already, and let's keep them coming. That's great. And thanks for these acknowledgements. That's wonderful as well. Let's continue now with Catherine Mesa. And Catherine, you can unmute when you're ready and go ahead. You have 8 minutes.
Gracias, Steve. Bueno, muy buen día y buenas tardes con todos y todas. Mi nombre es Catherine Mesa y hoy día les vamos a compartir el trabajo, ¿no?, que estamos realizando en descansos multifuncionales a base de forrajes desde los Andes centrales. Entonces, solo para compartir cómo funciona un trabajo tradicional. Bueno, prácticamente los suelos en los Andes tiene una rotación larga de cultivos, ¿no?, que empieza con papa, con maíz, algunos tubérculos andinos, cebada, trigo, y muchas veces ellos incluyen leguminosas. Y luego está acompañado de una rotación una rotación o un periodo de descanso muy largo, ¿no?, donde puede llegar hasta 5, 6, 7 años. Entonces, pero también esto ayuda a la recuperación de los suelos, ¿no?, a su recuperación de la salud del suelo, pero también tiene otro beneficio, que estos descansos son utilizados como áreas de pastoreo, ¿no?, así como ustedes pueden ver aquí en la imagen a la izquierda, ¿no?, pero por procesos sociales, por presiones económicas, por cambios de uso de tierra, ¿no?, estas rotaciones se vienen acortando. Ustedes pueden ver al lado derecho que la rotación no ha variado mucho, pero sin embargo el periodo de descanso cada vez se hace más cortito, ¿no? Incluso 2 años, 1 año no más para descanso, y en algunos casos ni siquiera hay descanso, pero también perjudicando a la disponibilidad de forraje. Entonces, en función a eso y para abordar estos dos problemas, uno de disponibilidad de forraje y otro para recuperación de suelo, con nuestros aliados hemos decidido instalar diversas mezclas de forrajes, ¿no? Especies de rápido crecimiento, ¿no? Que entre gramíneas, leguminosas, especies anuales, especies perennes, para que estas de alguna manera puedan ayudar a abordar estos dos problemas, ¿no? Mezclas muy comunes como avena con vicia, en otros casos mezclas más intensas entre especies perennes de leguminosas, gramíneas como reygrass, alfalfa, dactilis, etcétera. En algunos casos, algunas especies anuales, algunas leguminosas como el lupinus, y también en otros estas mezclas de forrajes han estado acompañados de algunas enmiendas como ceniza o diferentes tipos de estiércol, ¿no? Y en todos los casos y las comunidades y los trabajos que se realizan con las familias, también estas están acompañadas de un control que es un descanso tradicional. Así como ustedes pueden ver en la imagen a la izquierda, eso es un campo típico de un descanso mejorado donde el agricultor está haciendo, está haciendo el corte de la biomasa, ¿no? De las plantas en un descanso natural, y alrededor ustedes pueden observar cómo se ve un descanso a base de forrajes. Entonces, en función a eso, ¿qué hemos aprendido, no? ¿Qué ha aprendido el equipo, no? Entre las familias y las comunidades que están participando. Primero, que ustedes han visto que después de la última cosecha, el suelo en el primer año queda descubierto, ¿no? Ustedes pueden ver en la primera imagen, ¿no? El suelo queda expuesto a diversos procesos de erosión, ¿no? Porque hay un crecimiento lento de las especies, de las plantas en el primer año, mientras que en un descanso con forraje, debido a los forrajes de rápido crecimiento, este suelo se puede proteger. Entonces, de alguna manera se está disminuyendo los procesos de erosión, ¿no? Y además entendemos que estos suelos y estas montañas pues tienen una pendiente muy pronunciada, ¿no? Entonces, también entre otros indicadores que es muy amigable con los agricultores es ver la acumulación de raíces que hay en este primer año de descanso, no solo en cantidad, ¿no? Sino que también al sembrar diferentes especies de forrajes tenemos diferentes tipos de raíces que están quedando en el suelo, y también cuando se habla de calidad, porque también hay muchas leguminosas, ¿no? Que también están dejando raíces, no solo raíces, sino los nódulos, ¿no? De rizobia. Por otro lado, también hemos visto que indicadores como la macrofauna, ¿no? Que incrementa, por ejemplo, la cantidad de lombrices en la tierra, es muy importante para entender este concepto de la salud del suelo. Cuando hablamos de sinergias entre las leguminosas y las gramíneas, no solo los descansos a base de forrajes ayudan a que las gramíneas tengan mayor crecimiento gracias a la provisión de nitrógeno de las leguminosas, sino que también sobre el suelo se observa mayor presencia de polinizadores. Entonces, en términos de producción, ¿no? De producción de las parcelas a base de descansos con forrajes, se ha visto una mayor disponibilidad de forrajes, ¿no? Y cuando hablamos también de la producción, ¿no? También hablamos de mayor productividad de los principales cultivos, como es el cultivo de papa, ¿no? Ustedes pueden observar en la gráfica del centro, ¿no? Que los descansos a base de forrajes, especialmente a base de dactilis, reygrass, que son gramíneas perennes, contribuyen más a una producción de papa en comparación a un descanso tradicional. Asimismo, Perdón, Steve, ¿podrías retroceder? Asimismo, cuando hablamos de contribuir a la mitigación de cambio climático, para nosotros, el equipo, ¿no? Es importante también evaluar las condiciones de carbono en el suelo después de un descanso con forrajes de 3 años como mínimo, y hemos visto que hay una relación muy positiva entre la acumulación de forraje y el incremento de carbono, y esto también relacionado al manejo de los agricultores, ¿no? Al tipo de manejo y los insumos que ellos están aplicando a las parcelas, es decir, que se ha visto cuando hay mayor ingreso de estiércol, de materiales orgánicos, hay mayor acumulación de carbono activo en el suelo. pero no todo, ¿no? Son beneficios, no todo es positivo. También hemos aprendido y estamos aprendiendo con los agricultores, ¿no? Que hay muchos retos, retos con respecto, por ejemplo, a las familias. Muchas de ellas tienen mayor, o hay una tendencia a mayor crianza de animales, donde no, siempre la pregunta es, bueno, ¿hasta qué punto se pueden seguir extrayendo forrajes del suelo? Aunque a pesar ahora hemos visto que hay tendencias relativamente positivas, pero por otro lado también se ve que al tener mayor cantidad de animales, también hay una mayor acumulación, hay una mayor cantidad de estiércol, ¿no? De insumos orgánicos en las parcelas o en las fincas. También en nuestras discusiones hemos observado y también siempre se pone a la mesa en nuestros debates que en suelos muy degradados, en pendiente, ustedes pueden ver en la imagen arriba a la derecha, no, suelos de mucha pendiente, a veces los forrajes no se adaptan, ¿no? Porque hay mucha degradación. Entonces los agricultores dicen, ¿y ahora qué vamos a hacer? Porque solamente en algunas parcelas se adaptan bien los forrajes. Y relacionado a ello también hemos visto, a pesar que no en suelos en pendiente, que en suelos muy superficiales también presentamos los mismos retos, que algunos forrajes no se llegan a establecer como quisiéramos, ¿no?
You have 1 minute.
Ok, gracias, Steve. Entonces, también en otro sentido, ¿qué hemos aprendido de trabajar con los agricultores? No hemos aprendido que ellos son bastante minuciosos y siempre están en búsqueda de nuevas cosas, por ejemplo, de cómo trabajar con los estiércoles de diferentes tipos. Ellos identifican, ellos son investigadores in situ que identifican nuevos problemas, son muy minuciosos, pero también lo que quiero mencionar es que en este trabajo con agricultores, en alianza con ellos, hemos visto que el liderazgo de las mujeres mayores está vivo, ¿no? En estas comunidades, y creemos que esto es un ejemplo para las mujeres jóvenes, ¿no? Ver cómo las mujeres mayores lideran, y especialmente en este espacio de forrajes, ¿no? Es donde ellas se sienten más cómodas. Y por último, también hemos visto que este trabajo de descansos bajo forrajes, ¿no? Es una ventana para las nuevas generaciones. Como por ejemplo, hemos visto que en el proceso siempre los padres, las mamás van acompañados de sus pequeños, y nosotros consideramos que también es una responsabilidad para el equipo no dejar no dejar a un lado estas oportunidades, ¿no? Porque también creemos que es una responsabilidad para nosotros para contribuir en las nuevas generaciones y los nuevos agricultores y agricultoras. Y bueno, solamente un slide, es algunas personas, ¿no? Del equipo de Ayacucho, de Huancavelica, de Junín, de la Sierra Central del Perú, que contribuyen y trabajamos en alianza con ellos. Gracias.
Thank you very much, Catherine, for your talking about this nice case from the Andes. And now I want to move ahead with Chumba Burgu and Peter Goebbels, who will speak from a very different context now from West Africa regarding agroforestry concept. So you can go ahead when you're ready, Chumba and Peter.
Yeah, thank you, Steve, and hello to everyone. Yes, the context is very different, but the problem is similar. Traditionally, for generations, farmers have used fallow to recuperate the soil fertility, and there's no longer, many farmers don't have any more opportunities for fallow. So what can we do to improve soil fertility? And one of the things we found in the Sahel is that agroforestry, or more particularly FMNR, farmer-managed natural regeneration, is one of the solutions, not the only solution, but one of the main ones. Next. So what is FMNR, farmer-managed natural regeneration? Well, you can see the picture here. It's letting the trees, the indigenous trees that are already on the land, grow. And that is what, and farmers manage that. It's the way that they manage the trees so that they don't compete with crops. That is very important. Next. So how can this be done? We're not talking here about transplanting trees. We're talking about letting the trees that are already on the land grow. And it's because they're still, because of the fallow, they never pulled out the stumps. So you have all these bushes, what look like bushes, growing on many of the fields. And you can see here that the bush is just basically the shoots coming out from the old stump, which still is part of, has a vast root system. So there is, in all effect, you can't see it, a vast underground forest in many of the trees and many of the fields in the Sahel. Next. So what this technique of FMNR consists of is helping farmers learn how to manage those shrubs, or what look like shrubs, leaving one or two of the shoots and letting it grow into a tree. Thank you. Next. So here we have a demonstration of the FMNR techniques with farmer leaders. It's called RNA in French, which is Régénération Naturelle Assistée, but I prefer the English version, which is farmer managed natural regeneration. So the farmers decide on how many trees and what type of trees to leave on their land. Next. Now, a key technique of this overall approach is to prune the trees before the rainy season or during the rainy season, like you see happening here. So farmers normally think that trees are going to compete with their grain crops, but if it's managed well, it can actually improve the soil. And I'm going to show some slides shortly that show how this is done, and actually improve the yields of the crops. So here the trees are also serve as a windbreak. Next. So one of the key issues that we have with climate change in the Sahel is there's increased temperatures. Most crops, even millet and sorghum, are at the upper threshold of what they can stand in terms of extreme temperatures, which are already very high. And the Sahel is in a hot spot with more than, the temperature is increasing much faster than globally. So you can see here that the trees under the shade, dispersed shade, really help reduce the temperatures and make it more possible for crops to grow and withstand the higher temperatures. Next. Another benefit of trees in the way that they're managed is that they do what we call bioirrigation. During the night, the trees that have much deeper roots bring up moisture from the soil. And there has been research to show that this is transferred to crops, and you can see the benefit of it here of the plants doing the millet doing better under the tree as due to this bioirrigation. And there's a lot of research to show this. Next. And of course, the trees also leave mulch of the falling leaves, and that improves the soil underneath the canopy of the trees. So that also improves the water retention of the soil. Next. And what is also very important is that once you increase the density of trees, they have to be pruned. This also has the benefit of helping women who have increasingly less access to firewood. They have to purchase it, and then so they benefit a lot, or even can sell the surplus wood on the market. So this really reduces women's time and workload in collecting firewood. Next. Now we're talking about landscape. Here we have two photos. They're less than 500 meters apart. One is with FMNR, and the other one is where there's no FMNR. And you can see which landscape is going to be better for crops and for maintaining long-term soil fertility. You can see the effect of FMNR on the landscape. Next. Now, there's been a lot of research also to have shown that if managed properly, the density of trees can really have an impact on the soil. Here you have on the graph no trees, per hectare, 50, 100, 150, and we have had up to 200 trees per hectare. Of course, it depends on the type of trees and how you prune them and so on. And you can see the impact on the soil, not on the soil here, but on the overall yields of grain crops in those fields. So it can have. This is from Senegal. Next. Now, I should mention that even though we're promoting FMNR, that all the other things that you've seen, the grasses, the cover crops, the lab, the rotation, in our experience, all are necessary to combine in some way. That's why we call it agroecological intensification, and coupled with soil and water conservation. Here you see the rock buns that are Burkina is very famous for retaining the water on the land, with the trees and with other measures as well. So the trees are essential in our view, especially due to temperature, but are not the only way that we need to combine with other things, ways to keep the soil fertile and covered as much as possible. Next. So some of the barriers or challenges, of course, we got trees and they grow anywhere where there happens to be a stump. It makes land preparation, especially with bullocks and more so with tractors, to the extent that farmers have tractors, difficult. There's the tree tenure, who owns the trees, there's fire, there's animals that do grazing. And then there are fields where unfortunately there are no stumps left, and that makes it more difficult to apply. And finally, women's engagement is more difficult with FMNR as an innovation, because women have much less access and control over land. So their application of it is difficult. Next. So now we move from the technique itself, where the main technical issues related to research are the tree density and the diversity of tree species.
And you have 2 minutes, 2 minutes.
Okay, and FMNR is just one of the options. And now we're going to go through the link to FRNs. Over to you, Chomba.
Thank you, Peter. Next, please. Now we learn how FMNR is applied within FRN approach. So FMNR helps catalyze FRN because it brings together other actors at different level of responsibility around the farmer and communities, the main actors. The traditional authorities, the administrative, local government authorities, researchers, and their institutions. And finally, successful promotion of FMNR depend strongly on the indigenous knowledge of farmers and ability for adaptation. Next, please. What is the role of peasant farmers within FMNR? The farmer manage the approach to suit their own context and resources. They test and observe the different tree species and densities according to the recommendation of research or support structures, but also according to their own knowledge. They decide on what mix of benefits to obtain from the use of forest products, meaning fodder, firewood, fruit, and other byproduct income, in addition to soil fertility and adapting to climate change. They disseminate the knowledge about applying FMNR practices among their peers through training and experience sharing. Next, please. In conclusion, to get the maximum benefit from the FMNR, there is a need for a strong, frank, and respectful collaboration between the various stakeholders engaged in the agroecological transition. Each one brings to the group his or her specific expertise to contribute to solving the issue faced by the different farmer categories. FMNR is only one approach to the process of transition to a more productive, fairer, healthier, and more sustainable farming system. This process is more effective and has a wider impact if undertaken within the wider approach of FRN. Thanks for your listening.
Thank you very much to Chumba and to Peter, but to also all of our speakers. I know it was quite a task and quite rushed in some ways, but I'm really glad that you're able to share these things. And I really feel the presentations they're very nice, and so many images also of the different work that you're doing that help us to understand what's going on and also the principles involved. I think we have time for some questions. We have about 15 minutes. And maybe as we go through also, there may be others. Yeah, anyway, let's get to some questions. And then if there's some comments about maybe work that is other work that's going on with soil health that reflect some of these things, there might even be time for some sharing. I see a question here in the chat. Feel free to chat in your questions, and I think myself and Kelsey, who's helping out, will try to sort through them. I see from Wezi, and Wezi, I just want to acknowledge that you yourself have been involved in a very long-term project that really reflects these principles in soil health and doubled up legumes, pigeon pea, and other legumes in Malawi. So that's great. And I have an interesting question here on striga management for John, for John Ojem, about differences between legumes. So go ahead, John, if you want to answer that. Are there differences between different legumes in terms of, is bean equal to ground not equal to lab, let's say, for suppressing striga?
Okay, thank you, Steve. Our research indicates that, we have looked at striga suppression capacities of several grain legumes. And what we find out is that lab is the best, followed by groundnut, and then, followed by soybean, and then groundnut, and then bean comes at the bottom. So that is why in our promotion we are focusing on lab for striga suppression, but also because it is a legume that has a lot of biomass, the soil nitrogen supply, and also fodder.
Great, thank you. And let's see, there's another question here about, let's see, I have to go through the different introductions about quantification. Yes, from Sarah, good to see trees and the potential cooling effect they have for crops, humans, and possibly livestock. Is there any quantification of tree food supply, such as fruits or vegetable matter? Maybe that's for Chumba and for Peter. Chumba, do you want to?
There's no, there's a lot of research on effects of FMNR in trees, and also improving the FMNR in a way to also optimize access to forage for animals and also fruit. But the quantification is so variable because, it just varies from place to place, village to village, farm fields to others about what trees grow up, because all this is what trees sort of grow indigenously. It's not transplanting of trees, although we're trying to have FMNR plus to find ways to still increase the density. But so the quantification is, it's not easy to generalize about that. And it depends on the type of trees. There's tamarind, there's baobab, there's many types of trees that are more valuable, shea, that is far more valuable than others. So no, I'm not familiar with exact quantification, but it is substantial in many places.
Mm-hmm. I'm also noting the exchange about birds, which actually is a concern that you hear about in the Andes as well. When trees are planted, especially when they're the only trees around, you can have concerns about birds and eating grain crops. And there's a response from Peter, because there are already some trees there.
Yeah, maybe Chumba wants to chime in on that.
Yeah, that's fine. Go ahead, Chumba. Yeah, Chumba. Sorry.
Yes, this is a real concern, but if you have a lot of birds in your farm, also it can help manage some insects that will have destroy your crop. So we see some areas where people use trees to attract birds so that it can help manage pests and insects that wish avoid them using chemical pesticides. And if you live in your farm, you can also try and only by your presence, it can, how can you say,
Scare the birds.
Yeah.
Scare birds. And there are different techniques to put cloves and different things that can push back birds. Okay.
I see a very interesting kind of a broad question from Mahaman, I think. Thanks for the presentation. What do you see as the main research gaps for FMNR research? And maybe I would generalize that to, if there are some other research gaps that you're encountering. If you notice, all of these are kind of employing crops and plants, roots, keeping roots in soil, different, more perennialization or long season nature. In the case of Lab, this is a longer season, high biomass crop, those kinds of things. So what are the research gaps? Maybe we'll start with agroforestry and this more particularly FMNR. But what are the gaps that you see? What's needed?
There's a lot of gaps. There are a lot of things we still need to learn about how to integrate trees with crops and with animals. But one that's very important, which we haven't mentioned here, is that trees, as you all know, sequester carbon. So and especially there's a lot of carbon projects now, and people want to know, well, how much carbon is being sequestered by this FMNR? Because the potential is like millions of hectares of cropland that could increase the density of trees from maybe 20, 30 trees to 200 trees. And that's going to make a huge difference and contribute towards climate change mitigation. And we don't know yet how to assess, the level of, in the drylands, at least in the Sahel, what the level of carbon mitigation would carbon sequestration would be. So that's just one, and I could go on and on, but I'll stop.
Yeah, maybe right. And maybe are there some other gaps that John, you're seeing in the work you do, or Catherine, that you see? What are the next things you'd like to learn about, or probably that farmers also want to learn about, right? What's important to them in answering some questions?
Well, for me, I think that we are focused so much on Lab because of some very good reasons, but it is also something that farmers are learning how to use, and because Lab is kind of plastic the way it responds, so you see a lot of variation in the way it responds in different environments. So that is some kind of a challenge. Trying to find out which Lab varieties are good where, and so on and so forth. Yeah. We're also having a gap in terms of fitting such a legume in the system. I talked about large biomass production. So if farmers are land constrained, then they are trying to fit this in an intercrop. Then there are challenges because of high biomass production that is going to lead to smothering of the cereal. So there are gaps here and there. I think soil health is very knowledge intensive, and I think a lot of capacity building needs to be put in place, but also just scaling out this research in terms of going from plot to farm, finding the landscape and things like that. So I think there are several gaps if you look at it that way.
Great. And Catherine, go ahead. Yeah. Thanks,
Gracias,
John.
Steve.
Great.
Sí, o sea, hay muchos vacíos, ¿no? En términos mecanistas, se podría decir estudios que podríamos realizar, por ejemplo, cuando hablamos de nuevas especies invasoras, nuevas malezas, ¿no? Que eso viene también de la percepción de los agricultores, ¿no? Entonces ellos van identificando diferentes temas, cómo hacer un mejor uso del material orgánico, de los estiércoles, ¿no? O sea, yo creo que hay cosas que vienen de ellos, que esos son, que a veces nosotros no se percibe muy rápido, pero ellos lo ponen en discusión. Pero aparte de ello, también podemos hablar de escalamiento, ¿no? Yo creo que es una parte muy crítica en cuanto ya uno obtiene resultados positivos, ¿no? El cómo escalar, el cómo hacer que sea atractivo para más familias, para más personas. Esa parte también yo creo que es un vacío fuerte, ¿no? Donde tenemos que ser más creativos. Y por otro lado, también yo pienso que en este aspecto social, cuando hablamos de trabajar con familias, a trabajar con agricultores, yo creo que darle mayor espacio a las mujeres es muy importante. Al menos en los Andes, ¿no? Yo siento que las mujeres se sienten muy identificadas con el manejo de los forrajes, ¿no? Con la crianza de los pequeños animales como los cuyes o guinea pigs, las ovejas. Entonces, darle ese espacio a las mujeres y a los niños, yo pienso que también es parte de nuestra responsabilidad y también un vacío. He visto que ya somos muy sensibles a identificar esos problemas, ¿no? Pero no tenemos la suficiente, no sé si capacidad o las suficientes herramientas para luego dar el segundo paso, ¿no? Si ya identificamos algún aspecto social, luego cómo vamos a contribuir a ello. Yo pienso que también esta parte está muy relacionado a todo el trabajo físico que realizamos con y las agricultoras, ¿no?
Thank you. Yeah, and both of you meant the last two speakers, both John and Catherine. You mentioned scaling and scaling out in the sense of having this maybe cover a greater portion of the landscape, so you have some real significant impacts. And I think even that in itself can be a topic of research. I know that in the network trial in Kenya that you're doing, that's being studied as one of the angles. How do farmers more effectively communicate these things among themselves, like with videos or other things? So great. And let me just make sure we have until now 5 more minutes. We can continue talking, but the translation will go off. So we want to make sure we get in some questions here. Yeah, there was, let me just see. For Catherine, maybe go, Ed, do you have something? Sorry.
No, on the hour, we may have to kick you out though.
Oh, that's fine. Okay, sorry. I was told at some point that maybe we could continue, but that's fine. No problem. So let's finish up. This is good. Thanks, Ed, for the information. Great. So there was I think an interesting question about, Roberto, do you want to just say it? The question about land size or land quality, that was for Catherine, but maybe it applies to the other systems as well. It was definitely mentioned, I think, by Peter about, the quality of land, whether you have trunks, whether you have trees in your land. I don't know if Roberto is still with us. His question was, go ahead. Yeah,
I was just wondering, when Catherine was explaining these differences between steep land and flat land, and the techniques she's studying applies better in one type of land rather than the other, and the access to better land is not homogeneous within the community, it might create additional differences between the community in the social process, what she thinks about it.
Sí, definitivamente, Roberto. O sea, todas las tierras, ¿no? Independientemente si son planas o están en una pendiente muy pronunciadas, todas se orientan o son utilizadas para una producción agrícola, pero sí, definitivamente hay algunas que no tienen la suficiente capacidad para poder ayudar a un mejor establecimiento de los forrajes, ¿no? Y eso sí es una limitante y está día a día en las conversaciones y discusiones con los agricultores. Y para nosotros es un reto porque al final vemos que sí hay algunos resultados positivos de sembrar forrajes en las rotaciones de cultivos, pero también tenemos que ver por esa parte de que esta heterogeneidad de los suelos ¿no? Algunos en la zona baja, media, alta, y estas montañas de los Andes justamente nos hacen enfrentar estas dificultades, entre comillas, pero siento y soy muy positiva de que con la creatividad también de los agricultores y las propuestas de ellos es posible encontrar algunas soluciones, ¿no? Por ejemplo, antes no utilizábamos ningún tipo de estiércol para establecer a los forrajes, pero los agricultores dijeron, no, con estiércol podemos utilizar en tierras mucho más infértiles o con dificultades, y eso es lo que ahora estamos de alguna manera estrategias para mejorar esos establecimientos.
Gracias.
And I would quickly add that on in a more positive way as well, that the farmers themselves recognize differences in land quality and adapt to those practices to the particular, they know about the difference between slopeland and flat land and treat those in different ways. Sorry, so we should rush on now. We have, I think, 1 minute. I see a question about suppressing striga by beneficial fungi. John, is there any chance you can answer this? Have you heard of this bioherbicide? I don't know, maybe it can be. I also see a nice question maybe about the agroforestry, about copying the species in the place. That's from Mariana. So when you decide on the species for agroforestry, do look at what the natural forest would be in that area.
Just very quickly, it's not that we decide, it's what stumps are already in the ground. They're indigenous trees and which you can let grow. So that is and then you decide about which of those types of trees or all of them that you want to let grow to increase the density and diversity of trees on the land.
Great, good. So I think we're just at time here. I think we need to say goodbye now. I'm sorry, there's no way to continue the conversation. And we have one last comment there from Kenya on fusarium biocontrol and some literature. There's some published articles. Thanks, Beth, for that. And also this, I saw a recurring theme about soil carbon. This comment from Chumba about the need to study the soil carbon impacts, which I very much agree with. We're trying to do that as well. Okay, good. Well, thank you. And it's a little, it's a little bit of a quiet moment just to thank you and say we move ahead, and we'll see you tomorrow in the meeting if you're joining. And a big thanks to all of our presenters and all the farmers who helped in this work and helped in defining the work. Thank you.